Hi class, this is the video for section 8.1. Now 8.1 talks about basics of hypothesis testing. And the following are the learning objectives that at the end should be able to identify the null and alternative hypothesis statements about the parameter that you are testing about, a claim about, which could be a proportion, the mean, or the variance. Okay, you classify the test as two-tail, okay, two-tail, left tail, or the right tail. And there are two types of errors that occur in hypothesis testing. We're talking about that, how to differentiate them. And then when you have the claim, you do a test, a procedure, you have to, how do you write the conclusions about your claim, okay? And then there are two methods that we'll be using, the critical value approach or method, and then the p-value approach or method. You can use the critical value and the p-value. Either or will give you the same result. So I'll be showing you how. In this section, though, we will be looking at the setting up and what goes on in the testing. And then 8.2 will be more specific, and the 8.3 also will be more specific in testing hypothesis. All right. So some definitions, what is hypothesis? Okay, in statistics, it is a claim or a statement about the property of a population. So are you looking at the mean or the proportion if you conduct a survey, or is it about the population standard deviation? And then the test itself is a procedure for testing the claim. Basically, that's what it is. Okay. Now, this is also part of inferential statistics. So starting from chapter 6, we've been dealing with what inferential statistics. I'm going to continue until we finish, okay, in chapter 10. Now, let's look at this question. It says that it's about majority of consumers about drone deliveries, all right? We hear of these days Amazon and other companies want to deliver. When you purchase something, the drone will deliver it to you. Okay, so there was a survey of 1,009 consumers who were asked if they were comfortable having drones deliver their purchases. And it was, out of that, about 54%, which is also the same as 545. The way to get that value is that if you multiply this value by what? The sample size, how many were surveyed, you get that 445. Of course, you're going to round it up, finding the sample size. Now, they responded no, they don't want that. They're not comfortable. So you see that this is about what? A proportion. And so the parameter or the property about the population is what? Proportion. So we want to let this denote the proportion that consumers not comfortable with drone deliveries. Now, we want to claim that the majority, okay, claim is what? Whether it's equivalent to that, the claim is what? Greater, all right? So when you say majority, we are talking about what? It is greater than what? 50-50. So in this case, we want to let our claim is this. Symbolically, that's what it is. That the P is greater than what? 50%. Because we want that to be what? More than 50%. So the question is that sometimes when you give a question, I mean, if you look at the proportion or the sample proportion, which in this case is the 54%, all right? Well, is it really significant or not? Okay, so now let's look at some scenarios based on this. So here's the big picture. So when you have the claim that the population proportion is such that is greater than 50%. So among those surveyed, assuming that you have 506 of them said that they were not comfortable having the drone deliver their purchases. Now this is in percentage is what? 50.1. Of course, you see that 50.1 is not too far not far from what? 50%. So we can see that this barely more than what? Half of what? The people who were surveyed. So we can say that this is not significantly what high. On the other hand, if you have 1,006 out of 1,009, which is 99.7%, you can see clearly this is what is high or significantly what high. But in our case, based on the question, the 54%, okay, the question is that, is it high or not? You can say, oh, just only 4 points, then it is not high. You need to what? Test what? The claim. That is why this section or this chapter, it is very important. Okay, so we need to identify our null hypothesis. The null hypothesis denoted by what? H subscript O. And then the alternative is what? Either H1 or H subscript small a or capital A, depending on what? How you write it. Okay. Now, what is the null hypothesis? It's a statement that the value of the population parameter, whether it is a P or it is a mu or it is this, is equal to, please note that it is equal to what? Some claim what value. And so for the null hypothesis always stated in this form, okay, the parameter is what? Equal to some value, whether it is P or mu, okay, or it is what? Sigma. Now the alternative hypothesis, okay, is a statement that the parameter has a value somehow differs from the null hypothesis. And this could be what? It could be less than or greater than or not equal to. Okay, now each of these tells us what type of test it is, whether it is one tail or two tail. Now if it's one tail, it could be left tail or right tail. Okay, so we talk about that in the next. So here's an example that I'm claiming, I'm making a claim, okay, about my population what? Mean. Population mean. Okay, so my null hypothesis is always, like we said, for the mean is equal to what? A certain value, and that value we want to call it what? A test value. The alternative has three options. If it's a two-tail, then the alternative is what? HA, or this could be what? H1 is what? Mu is not equal to what? The test value. Okay, that's a two-tail. So when you have alternative being this, it's a two-tail test. Now, if the alternative is that it is mu is less than, if it has this symbol, okay, if it has this symbol or this inequality, then it is what? A left tail test. Now, on the other hand, if it is what? Greater than, then it is what? A right tail test. Okay, so now let's define other terminologies. Now we have rejection region or the critical region. So the set of values for the test statistic, please, that causes the rejection of the null hypothesis is what we call the rejection region or critical region. The non-rejection region is the opposite of that. That the test statistic that leads to non-rejection of the null hypothesis. And then a critical value, yeah, it depends on what type of test. If it is one, is a left tail or right tail, then it's a one go critical value. If it's two tail, it has what? Two values. Now this value is what? Is a test statistic that separates the rejection region or non-rejection regions. Okay, a critical value is considered part. It's important to know that it's part of all the rejection region. Okay, so I try to put this some diagrams to explain this further. Okay, but let's talk about the procedures. Sorry. Okay. Now, For any hypothesis test, these are the following general procedures. You always need to identify your claim. Okay, that's the first thing. And then symbolically, whether your claim is about the proportion, whether it is what, less than, greater than, or not equal to. That's what I mean by the symbolic form of the claim. Then you identify your null hypothesis and then the alternative, HO, and then what, H1 or HA, the alternative hypothesis. Now, after that, you need to select your alpha, which is your significance level, and then you calculate your test statistic. Then you can either use the p-value to decide, or you can use the critical value to decide. Okay. Again, in this section 8.1, I'm just laying down the foundation and be more specific in sections 8.2 and then 8.3. Okay. So this is a general procedure. So the steps are the following. For a critical value approach or method to test, to hypothesis testing are the following. Okay, you state the null and the alternative hypothesis. You decide on the significance level. You don't finish your research before you decide on that. The significance level must be determined before you start. You compute your test statistic, determine the critical value or values. Okay, and if this is how you decide, if the value of the test statistics falls in the rejection region, then we reject the null hypothesis. Otherwise, we do not reject. And then, of course, you got to interpret or state your conclusion in the context of the problem. Okay. If you use some diagrams, this is what happens. For a two-tailed test, okay, your alpha, or what you call the significance level, is alpha. For a two-tail, you divide that by 2 so that the tails, when you add them, the sum of that will give me alpha. Okay, for a two-tail, if I'm using the p-value, the p-value depends on the test statistic. So if it falls in the rejection region, then you reject the null hypothesis. So if it falls in the tails, we reject. If it falls in the middle, we do not. Okay, for a left tail, your alpha, you don't divide by 2, or right tail, you don't divide by 2. It's just alpha. So if your test statistic falls, or your p-value is in what? In the rejection region, then we do what? Reject the null hypothesis. Okay, the same for what? For a right tail. All right. Now, what are the steps for a p-value? The first 3 steps are the same for both methods. The first 3 steps, you state your null hypothesis and alternative, you decide on alpha, you compute your test statistic. But step 4 differs, step 4 and 5 differs from the critical value method. Now here, you calculate a p-value. I'll show you how to calculate that using the table or get it from the StatCrunch. Now, this is what your decision is. Irrespective of the type of the test, whether it is left tail, right tail, or two tail. If the p-value is less or equal to alpha, which is your significance level, then you reject the null hypothesis. So this is very important when you are using the p-value method. Otherwise, you do not. Again, I repeat, it does not matter whether it is a left tail, right tail, or two tail. The p-value is what? If it's less or equal to alpha, then reject the null hypothesis. And as always, state your conclusion in the context of the problem. Okay, so now, this is what happened for a two-tail, for a p-value approach for the same diagram, similar to what we saw under critical value method. Okay, so when a p-value falls in the rejection region, reject. For a two-tail, the left tail, if it falls in that region, you reject it. For a right tail, if it falls in that region, you reject the null hypothesis. Okay. So identify the test statistic. So the question is given, how do you know whether you're going to use what? A z-test or a t-test? How do you know? Okay. Now, test about the parameter if it is what? Proportion. That is, we use a z. So it's normal. We cannot approximate that to normal distribution. And this is our requirement. Okay. We talk about 3 requirements. This is the main part, that n times the what? The p, which is under the what? The null hypothesis. If it is greater than 5, or if you n times the q, if it's also greater than or equal to 5, then we use the z. And that test statistic is given by this formula right here. Now, test about the mean. If we do not know sigma, then it's a t, as we said in section 7.2. If we know sigma, then it is a z, and that is given by this formula. So this is my test statistic for testing about the mean, population mean, when sigma is known. Now, if sigma is not known, I use the t, which is this formula. Now, for test about the standard deviation, we call it what? Chi-square. Okay, CH chi-square, like that. But we will not consider this part. We will only concentrate in this class. This refers to either proportions or the mean. Okay. So we can also use confidence intervals, but I'm not going to talk more about this. But this is just for information that equivalent methods, whether it's a t-value or the critical value method, this is also equivalent. That is a confidence interval equivalent to a hypothesis test in the sense that they always lead to the same conclusion. For parameter, they don't. It doesn't work that way. But for mean and what? Standard deviation, it will always arrive at what? Same conclusions. Okay, so this is just an information I'm giving you. We'll not be using this for a formal testing, but we can also use a confidence interval to test about the mean. In fact, if you remember, we'll be using the confidence interval to see whether it is overlap, as we saw in section 7.2. Right. Now, how do you write your conclusion? Okay. If your original claim does not include equality, and you reject the null hypothesis, okay, you say that there is sufficient evidence to support that claim. If it does not include equality and you fail to reject, there is not sufficient evidence to support the claim. Now, original claim includes equality and you reject the null hypothesis. Okay, in this class we'll be using that a lot. Then there is what? Sufficient evidence to warrant rejection of the word of the claim. Or you can say that there's sufficient evidence to support the claim. Okay, and the original claim includes equality and you fail to reject, that's how you write your conclusion. All right, so now let's look at this problem. I'm going to just set it up here and we'll bring the same example in section 8.2 and we'll solve that in detail. So the same question we have, majority of consumers are not comfortable with drone deliveries. Out of 1,009 consumers, 545 do not like the drone to deliver their purchases. Okay, we can use the critical value approach and then what? The p-value approach. So here, like I said, I'm going to set it up and then we will look at, solve it in detail, finish it in what sections 8.2. Now remember, it's all what majority. So if it's majority, it means that more than half of what? The population. And we have found this, okay, which is 54. So the question is that is this difference of 4 points really significant or statistically was significant? Okay, so we're going to set it up using critical value method and then p-value method and decide what kind of tail it is. Okay, so here I'm going to write A here. This is what critical value method. Okay. Now, what are the steps? Steps are the same. Step 1 says that state your null hypothesis. Okay. The null hypothesis includes what? This is a proportion parameter is what? P. So your HO is said that P is equal to what? 0.5 versus the alternative H1 is that is that it's more than majority. So P, okay, it is greater than what? 0.5. Now, we want to, before even we do this, we have to check the requirements, right? Okay, we'll do this again in 8.2, the next section. That here my n, okay, our n is what? 1009. Okay, so my p, I need to find n times p, which in this case is what? 1009 times 0.5 will give me 504.5. And then what is my q? Q is 1 minus p, which is also 0.5. So let's find p, n times q is also the same, it'll be 504.5. Now see that both of these are what? Greater than what? Both are greater than 5. Because the requirement says that is we have, actually in this case we have 1,100 individual trials, so they are all independent. Okay, if it says that NP is greater than what? Is greater or equal to 5, and not all, and NQ is greater than 5, then we can use what? The normal distribution to approximate the binomial. Okay, so that is step 1. Step 2, according to the question, okay, it said what? Use what? 5% significance level. So my alpha is what? Is 5%. 0.05. So step 3, it says that calculate the test what? Statistic. So test statistic, which is a z, is given by the formula is what? P hat minus p over the square root of p times q divided by n. Okay, now what is my p hat? Well, we know that your number of your p hat, as we know before, is given by x over what? N. Now the x is given by the 0.554 times 1009, which is give us the 545 that we talked about. So then I can calculate my z, which is in this case will be 545 divided by n minus the p is this under the null hypothesis, this value. So that is what? 0.5, then divided by the square root of 0.5 times 0.5 divided by 1009. Now this will give me, if you calculate it well, you will have 2.55. Okay, so you have step 3, that's your Z test statistic. And then step 4 is what? To find your what? Your critical value. Now since this is what tail is this? This is a right tail. It's a right tail test. Okay, so to find your critical value, don't have just one value. Now your alpha, remember, if you're using the table, okay, it's a right tail. So we want to find the Z value here, where alpha is 0.05. Okay, so Z subscript 0.05. What is that? What is this value to the left? And then this is equal to 1.645. To use the table, that's the value you get. Okay, because we want this side is to the left is what? 0.9195. And it falls between two values, and take the average, that's what you get. Okay, then we can decide. Okay, if I want to decide, look at it. This is, if it falls here in this region, we reject the null hypothesis. Now, this is my critical value. So my critical value Z 0.05 is equal to 1.645. And so what is my, if I compare this with my test statistic, which is here, okay, you see that the test statistic will fall within that region. Let me pick a different value, color. The test statistic is somewhere there, okay, it's somewhere here, which is 2.55. It falls in the rejection region. So this says that I reject what? HO. So you can say that since, okay, the test statistic is greater than what? The critical value. Reject HO. Okay. So that is how we use the word critical value approach to decide on that. Okay. Now, if I want to use the p-value approach, okay, we said that the first three steps are the same. So 1, 2, and 3 will be the same. So the only difference is that I need to find what? The step 4. That is calculate the p-value. Okay. Now the p-value in this case is given by a probability. Okay. It's going to be the probability that my Z, because it's a right tail, is greater than the test statistic 2.55. Now we know that this is going to be 1 minus the probability that Z is less or equal to 2.55. Okay, so 1 minus, when you find your table, okay, if I read this from my table, I get, I need 2.55. So 2.5 under 5 is 0.9946. So my p-value is 0.0054. Okay, so if I'm using it to decide, it says that if p-value is less or equal to alpha, then reject HO. So in this case, p-value in this what 0.005, sorry, yeah, 54. It is less than alpha, which is 0.5. And so in this case, we what? We reject what? The hypothesis, which is the same conclusion we'll arrive at when you use the word the critical value approach. Okay. Now we'll come back to this question again and solve, kind of repeat what we have done. Okay. And I also will consider other tails in the section 8.1, 8.2. All right. So we're going to be careful. There's a caution here. Your p-value, please, is not the same as what? Your population proportion. Neither it is the same as your sample proportion. Now these are different values. They are totally different from each other. So remember that. All right. Now let's go to the type of errors that occur in what? Hypothesis testing. There are two of them. Now, before I go on, you know that there are people incarcerated that did not commit any crime. Okay, they are innocent people who have been jailed, and they are guilty people who have been freed. So these are errors in statistics or in testing hypotheses. Now, somebody commits, arrested and then sent to court. They need to find evidence. They assume that this person is innocent unless they find evidence to support the alternative. So your null hypothesis that the person has done nothing. And then they investigate, and then they call, they deliberate the arguments, and they bring their cases, and then they're able to show that no, the first assumption is not right because there's enough evidence to support the alternative. Okay, so this is what is happening, and I'll give a specific example that we know. Now, two types. Type 1 error is this, that we reject the null hypothesis when in fact it is true. In other words, somebody is innocent, but the person went to jail. Type 2 is that we know that the null hypothesis is not true, it's false, but we fail to reject it. In other words, somebody committed a crime, but he went scot-free. Nothing happened to him. Now, I like this example that I used in my class. This is O.J. Simpson's first trial case. Okay, is it type 1 or type 2? If you remember, the null hypothesis says that O.J. Simpson is innocent. And then the alternative that he is not innocent. Now, if you remember the story, those who have been live longer, it was about a glove that didn't fit, so they let him go. It is rather the second trial that put him in jail. He finished serving his sentence, I think last year or last 2 years. Okay, so what type of error is this? The first trial, everybody, most people in America believe that O.J. Simpson committed a crime, the murder. He murdered the wife, but he was scot-free. So what type of error is that? Let's go back. It says that type 1 is that we know type 1, null hypothesis is true, but we reject it. Type 2 is that we know null hypothesis is not true, but we fail to reject it. In other words, we accept it. So what type of error is that? Okay, this is the type 2. So most people believe O.J. Simpson was not innocent, but there was not enough evidence to prove this in court. So the guy was free. In other words, most people believe that the null hypothesis is false, but was not rejected at his first trial. So this is what type 2 error. Okay. So significance level, the probability, what is it? The alpha that we are talking about. Okay, so the alpha is typically what? It is what the probability of making type 1 error. So that's why we set this to be very small. That you actually, if once you control type 1, you indirectly control type 2. So you don't want to control both of them, just one of them is enough. Okay. Now, what do we mean by type 1 again? The null hypothesis word is true, but we reject it. Okay. So let me go to so one example here. I think I'll do other examples on Wednesday, and then we'll finish this section. Okay, let's go to share my screen. Okay. Something. Okay, I'm doing 8.1, question number 7, just to show you. Okay, so let's preview that quickly, and I'll show that in a minute. So question 7 is this. Okay, let's go and share that. Okay, so here is question 7. He said that identify type 1 and type 2 error that corresponds to this. Now, what is type 1? That your null hypothesis is what? It is true, but we reject it. The type 2 is that the null hypothesis is false, but we fail to reject it. So, the percentage of high school students who graduate is less than what? Graduate is less than 55%. Okay, now let me share I need to state my null and then alternative hypothesis, okay, so that you know the difference to be able to decide. Okay, so in this case, your HO is that the P is 0.55 versus the alternative. The P in this case is said less than. I'm making sure I have that. Yeah, it said it's less than. So that is what? Less than what? 0.55. Now this is a left tail. Okay, so if we fail to reject, okay, what is type 1 here? Okay, rejecting HO when it is what? True. And then type 2 is what? Not rejecting. Not rejecting the null hypothesis HO when in fact it is what? It is false. Okay, so let's go, and we have written our null and the alternative hypothesis and decide. So which one is type 1? Okay, A, he said you failed to reject. There was a claim. The claim is that the high school students graduate is well less than 55%. Okay, now that goes to the alternative. Remember that. So you fail to reject the null hypothesis that the percentage of high school who graduate is equal to, okay, 55 when that percentage is actually less than what? That. Okay. You reject the null hypothesis that the percentage of high school students who graduate is equal to 55 when that percentage is actually equal to what? 55. Okay. Type 1, you reject the null hypothesis when in fact it is true. Okay. So this will be what? That would be B. Now, what is type 2? Let's continue. Type 2 is this. Okay. That is failing to reject the null hypothesis when it is false. My null hypothesis in this case is that it is equal to what? 55%. Okay. So we're going to fail to reject the null hypothesis that the percentage of high school students who graduate is what? Okay. Because the null hypothesis is not less than, it's actually equal to. So fail to reject the null hypothesis of the percentage of high school students who graduate is equal to when that percentage actually is what? Less than. That means when in fact this is what? The null hypothesis is what is false. But we fail to reject that. So this would be your what? The type what? Type 2. Okay? All right, so we will end here and pick up some, do some examples in class on Wednesday. Thank you.